The curve C has this equation here. Find the coordinates and the nature of each of the stationary points of C. Sketch C, indicating the coordinates of each of the stationary points. Given that this equation equals K, has only one real root, find the range of possible values for K. Okay, let's have a look at it then. Let's do part A. And we'll move part C and do that another time. So part A first of all then. Stationary points. A dy dx. Here we go. Differentiate then. 3 comes down. 3x to the 1 less, which is 2. 2 comes down to be with the 3 to make 6. X to the 1 less than 2, which is 1. X goes to 1, minus 9 lots of 1 is minus 9. And the constant goes to 0. Let that equal 0. Divide by 3 all the way through here. You can see that x squared minus 2x minus 3 equals 0. We need to factorize this. 3 ones, let's try 3 ones. It's a minus, so we'll have a minus 3 plus 1. And that tells us then that x is equal to minus 1 here is one turning point, and x equals 3 is the other stationary point. Okay, so they're nature now, so we need d2y by dx squared is equal to 2 comes down to be with the 3 to make 6, x to the 1 less than 2, which is 1, minus, x goes to 1, minus 6 lots of 1 is minus 6. So when you put minus 1 in here, it's 6 times minus 1 minus 6, which is minus 12. So this would be negative, so a max. And when we put 3 in, we'll have 6 lots of 3 minus 6 equals 18 minus 6 is 12. So a min, because it's positive, so a min. This was when x is equal to minus 1, and this was when x was equal to 3, the 3 value. Okay, so we got our min and max then. Coordinates, so x equals 1, y is equal to, remember what it was? It was x cubed, wasn't it? Minus, let's just go back up and get it. Minus 3x squared minus 9x plus 14. Minus 3x squared minus 9x plus 14. Let's just check that. Yeah, that's fine. So that's what we've got. So let's put the values in when x is 1. Let's see what we get. So we end up with then 1 minus 3 minus 9 plus 14, which is 15 take away 12 is 3. So it's 1, 3 is the coordinate of the turning point. X equals, oh, sorry, it was minus 1, wasn't it, as the value. So we better put that in, that helps. Minus 1 cubed, minus 1 squared, minus 1. So see what we get. That's minus 1. This is still minus 3. This is plus 9. And this is plus 14. So we've corrected the mistake that I've made there. So what have we got? We've got 5. 9 minus 4 is 5 plus 14 is 19. So that was 19. Yep, and that was 19 there. So x equals, that was the x equals 3 value. X equals 3 then? No, that was x equals minus 1. I'm getting there slowly, aren't I? And then y is equal to, let's do this one then. Cubed minus 3 times x squared minus 9 times x plus 14. This time we're inputting 3 as our x value, our input value. And we get 27, 3 cubed, minus 3 cubed, 27, minus another 9 3s are 27 plus 14. These two will cancel. Minus 27 plus 14 is minus 13. So we've got the coordinate 3 and minus 13. Okay, these are our coordinates for our turning points then. That was -1, of course. Okay, so that's that then. Sketch C indicating the stationary point. So let's move on and do the sketch now. Because space is limited and I've got a digital pen, I'm not going to do it too large. I'll just do a small sketch, if at all, if possible. X and Y axes and 0. Now the turning points was -1 and 19. So -1 and 19. So I'm going to put that here. That's -1, 19. Not different scales on the X and Y axes, of course. And then 3 here, and -13. There's 3 and -13. Now we know that when X is -1, we have a max. And we know that when X is 3, we had a min, didn't we? So the curve comes down. Oops. I've got a digital pen, so it's tricky to draw, so I'll do my best. And it's going to come down, swing through the minimum, come up to the maximum, and then swing back down. This value here, just of interest, is when X is 0. And this value when X is 0, all these would be 0 and we get 14. So this height would be 14. Okay, so I think that's enough information there for the sketch. Right, so we've done part B, sketch C, indicating the stationary points, which we've done. Now part C to finish off with then. Given that this equation, which is our curve, equals k, has only one real root, find the range of values of k. When does that have one real root? Well, it tops off here, so I'm just going to do a line through the sketch so I can see it. And it bottoms out here, doesn't it? Oops. So we can see that anything below here will have one real root, and anything above here will have one real root. So here for part C, k would need to be bigger than, it can't touch because then it would have 2. It must be bigger than 19, or k would need to be less than -13. So either of those ranges, it would be fine for k. So I'll just get rid of these if I can. That was just helping me see what was what. So just tidy that up. There. Okay.